Hello guys, welcome back to my YouTube channel. In this video, we'll be learning about the psi angles. So the question for today is, in the representation of the dipeptide shown below, the superscript -1 denotes the atom of the previous amino acid, while +1 denotes the atom of the next amino acid. The atomic coordinates of how many and which of the following atoms are required to uniquely define the torsion angles phi and psi of the Ramachandran plot. Now, first thing that we have to consider is that in this image, the box is on an individual amino acid and not on the peptide bond itself. Now, let's learn about the phi psi angles. So, as you can see in this image, there are two amino acids, and this is the peptide bond. Now, when two or more amino acids are linked with peptide bonds, they'll try to arrange themselves in a way to minimize the free energy for maximum stability. Now, how this can be achieved is by rotating so that there is a minimum clash between the R groups or the side chains, which are denoted by triangles in this image. Now, this can be achieved in two ways. First, with the rotation around the bond between C alpha and carboxylic carbon of the first amino acid, something like this. Now, this is a turn of 180 degrees, and this turn is happening around the bond that is between C alpha and carboxylic acid carbon. Now, the degree of the turning is defined as the torsion angle. It is denoted by psi. And to describe this, we need the coordinates of four atoms: the nitrogen of the first amino acid, C alpha carbon, carbon of the carboxylic group, and nitrogen of the second amino acid. Now, there is another psi bond in this image. Can you guess where it is? I'll give you a second. So, the bond is between C alpha and carboxylic carbon. So, here is the second bond on which uh, the psi torsion angle are applied. Now the second bond which can be turned is the bond between alpha carbon and the nitrogen, like this. And the torsion angle defined by this bond is called phi. Now just like the psi, there is another phi in this image on amino acid 1, that is here. And the atomic coordinates which are required to define the phi angle are C alpha, nitrogen, then again carboxylic acid carbon, and C alpha of the next amino acid. Now coming back to the question. So we know that we need four atoms. So we can say that the answer is either option 1 or option 3. Now, just as we saw that the only atoms which are required to define these torsion angles are carbon and nitrogen, no oxygen or hydrogen. And since the option 3 contains hydrogen for the phi angle and oxygen for the psi angle, it is the wrong one. And by this elimination, we can say that the correct answer is option 1. Now, moving on to Second question, a bit more practical application of the phi and psi angles. So in this question, we are given the Ramachandran plots for four different proteins. Uh, the x-axis is the phi angle and the y-axis is the psi angle. Now, from these graphs, we have to determine which two of the proteins are predominantly alpha helical in nature. Our options are option 1, A and B, option 2, A and C, option 3, B and D, and option 4, C and D. So, to know this answer, you have to first know what are the common phi and psi angles for different secondary structures of the proteins like alpha helix and beta sheets. Now, these angles are determined experimentally, and you'll just have to remember the ranges of these angles. Now, here is the image to use as a reference, which shows the phi and psi angles of all the commonly occurring secondary structures in the proteins. Now, by looking at this image of the reference plot, we can see that alpha helix is located in the lower left quadrant. So now we have to choose the proteins which have uh, most of the residues in this quadrant. So by looking at all four options, we can see that one of such proteins is protein C, which has most of the residues in the region for alpha helix. So again, this gives us 50-50. Our options, our correct answer can be either option 2, which is A and C, or option 4, which is C and D. Now, let's look at both of them one by one. So, looking at option protein A, we can see that most of the residues are in the region corresponding to beta sheets. And when we look at the same region in protein D, we can see that the number of residues are very few. So if we have to choose that which one is particularly alpha helical in nature, we can say that D has relatively more alpha helical residues compared to protein A. So in this question, our answer will be option 4. Now, few more questions can be asked from the same information. Like if an examiner really wants to test your memory, then they can just outright ask you the exact values of the phi psi angles for any of the secondary structures. Like I can simply ask that out of the four options, which one are the correct phi psi angles for alpha helix. Now, obviously, that will be more difficult, but in general, if you can remember the approximately ranges of the phi psi angles for different secondary structures, it can help you to solve similar questions. For example, just the Ramachandran plot of the protein A in this question can be given as a separate question, and you can be asked to describe what all type of secondary structures are present in this given protein. In which case, the answer will be, we can see that there are mainly three secondary structures present: beta sheets, right-handed alpha helix, and some of the left-handed alpha helix also. And in similar way, with the Ramachandran plot of the protein C, you could be asked that which one of the secondary structure is absent in this plot. Let me know if you have any doubts regarding the Ramachandran plot or the five side angles in general. I'll try to explain them in a better way. If you like this video, share it with your friends who are preparing for any of the exams or even for your general college preparation, your college exams. And keep visiting my channel to learn more about the life sciences. Thank you.